What is that we do in the morning is very simple. Like if you see the fourth unit, we have only three or four concepts which are very important. The first one we have to discuss is semantic networks. This is one way of representing your NLP statements. Like whenever you have a statement, you consider the meaning of it and you have a diagram for that. And then you have conceptual dependency, which is also very important. And you also have a very important concept called as scripts. And then a very simple concepts called as frames. So if you consider the external exam or internal exam, whatever exams that we face, what is that they will ask you is what is the purpose of semantic networks? What are extended semantic networks? And how the inheritance is used in semantic networks? And most importantly, they will ask you what is conceptual dependency, why we need to use conceptual dependency, what are the idioms and primitives that we use in conceptual dependency. Then what is the difference between conceptual dependency and scripts? And how can a scripts represent a particular scene? And we call frames are called as data, we can informally call it as a database management system for a log. How can we represent frames? Frames almost will be similar to what you have seen in database management system. This is how it is. So, if you consider semantic networks, in general, what is semantics is the meaning of what we have written. So in C language, whenever almost there is a semicolon, the compiler will understand that the completion of sentence is completed. So obviously, whenever a C compiler sees this main, the meaning is the program execution will start something like that. So every construct in programming languages, we have some meaning of that. So what does your semantic networks will do is how can we draw a diagram by using set of meanings that are attributed. So somebody like somebody has written John is running. Like somebody says that John is a man. John born in Bhimvaram or something like that. John is a mammal and each mammal has legs or something. I have written some set of connected statements like this. So even if you consider database management system also, if you see the definition, it will be something like how can you store related data at some point of time. The same way, when you're creating some semantic networks, what is that we need to have is we need to have uh, connected statements, NLP statements. John is a man. If somebody writes like he is something called as John, and you can use easy or instance. I will use instance here. Somewhere around he is a man. And John was born in Bhimbaram. We can use like this. John is a mammal. So what is it I can do is, if I write a man is a mammal, then I will write this like this. A man is a mammal. And each mammal has X legs. So if has or something like that. So what is the interest of drawing all these diagrams is like you'll be asked a query like, does John possess legs? You need to validate that statement. Like if somebody asks you like, does John has legs? Is it a valid inference? John is a man. John was born in Bimbaram, and a man is a mammal. Each mammal has legs. Or does John has legs? If somebody asks you what is the inference is right, is it true or false? Can you hear me or I'm muted mode? See, I have a statement saying that John is a man, and I have a statement saying John is born in Bhimbaram, and a man is a mammal, and each mammal has legs. So, does John possess legs? Is it right or wrong?
Right, sir.
Right. So, how do you say it is right? Is means when there is a path from John to legs, I say that inference is right. So, in semantic networks, what they do is you will have a set of objects like this: John, man, mammal, and you have some relationships like what you draw in air diagrams. Whenever there is a path, then we can say that the inference is valid. This is how the semantic networks are created. So if I say every man has a name, John will also have a name, or every man will have every man belongs to a particular place. If I say something like this, so John will also will be a part of some place. So he reside in some place. So in the same way, like if you see the last time when your seniors are writing the exam, they have asked a query like this. Where is that query? So this is a simple thing that they have asked. Like they have given some connected statements like this. Tom is a cat. Tom caught a bird. Tom is owned by John. Tom is ginger in color. Cats like cream. The cat sat on a mat. And cat is a mammal. And this is what we have discussed also in the class. But what they have asked is what type of inherences or inferences that you can get from the statements. How do you represent this in the form of semantic networks? How do you represent this in the form of a semantic network? That's what they're asking. How do you represent that type of statements in semantic networks? So obviously, what is that we can do? We'll just try to do it here itself. So there is what was asked. Tom is a cat, so obviously there is somewhere we need to represent this Tom and cat. How do you connect statements with respect to the meaning that was associated with the statements is what your semantic network is. Tom caught a bird. So Tom caught somewhere called as a bird. Tom is owned by John. So there is a owner for this Tom. His name is John. Tom is ginger in color. So there is a color for this particular cat. Tom is owned by John. Cats like cream. So there is a cat. So it likes cream. The cat sat on a mat. So this cat at this moment sat on a mat. Cat likes cream. Cat sat on a mat. So cat sat on a mat. A cat is a mammal. A cat is a mammal. That's what they have given. A bird is an animal. Bird is an animal. All mammals are animals. Every mammal is an animal. And mammals have fur. So I'm drawing this. Mammals have fur. So I will write like this. So the question that they have asked is draw the semantic network for this particular set of connected statements, and we have drawn that. Then what type of inferences that you can get from this diagram? Can somebody just tell me what are the inferences? Does Tom has fur? Or does this Tom has a fur? Is that a valid inference?
Yes, sir.
So there is a path from one node to other node. If there is an inference from this one point, like you start from Tom and you end at fur, so obviously that inference is right. And does Tom likes cream? There is a path here, so obviously that statement is also correct. So indirectly, Tom is also an animal, so that statement is also valid. So you draw the semantic network, and then what is that we do is we try to infer something from this network. That is a theoretical way of representing knowledge and theoretical way of validating the inferences. So if somebody asks me what is the purpose of drawing a semantic network is, you represent the natural language processing statements in the terms of a diagram. From that diagram, you need to validate the inferences, whether the inferences is true or not. form, something like that. If there is no path from one object to other object, the inference is wrong. If there is a path from one object to other object, then the inference is right. So the first thing that we said is like today we need to discuss something about semantic networks, which is very important because every time, even uh, many people even introduce, they'll ask you about conceptual dependency. Once you have to understand this conceptual dependency, we need to understand the semantic network. How do you draw a network based on the meaning of the statements that you have given when all the statements are connected to them? That is what we call it a semantic network. But if you have a statement like every mammal is an animal or a mammal is an animal, there is a difference. All mammals are animals and a mammal is an animal. Is there a difference between these two statements? A mammal is an animal. All mammals are animals. Is there any difference? Both are same. Is there a difference or both are same? Or I will write something different. Like last time I have written something like a dog has bitten a person. All the dogs do you have does there any change between these three statements? All these three statements are same or different? A dog has bitten a person. All dogs in the city or all the dogs have bitten a person. All the dogs have bitten all the people. Is there a difference between these three?
Yes, sir.
So if you represent these three in semantic networks, it's very difficult to understand where this quantifiers are there. So all we need a different quantifier. Their existential, there is a different quantifier. If you represent this in the terms of a diagram, it's very difficult to represent this type of thing. That is the reason we have a concept, very simple concept called as partition semantic network. We call it as partition semantic network. We'll just try to. A partition semantic network is very simple, like I have written a dog has bitten a person. And then you have a similar type of things like all dogs has bitten a person, all the dogs have bitten all people. So when you have three statements are related, and then what is that your partition semantic network will do is, so you have something called as a dog, you have something called as a person who was the victim, and you have different types of bites based on the intensity of that biting. So what is that the semantic partition semantic network do is like you have a dog something like you take some D. D is a dog, and this is bitten. Like you take bite because many types of bites are there. So based on that bites, the intensity will change. Like you take some B is a nature of or is a type of bite. And you have a person and you take some P which represents that person. And then who is the attacker? Is the dog or the person? Is the attacker, assailant, whatever it may be. And person is the victim. This is an attacker, this is the victim. So theoretically, what they do is when you have three statements or four statements which are connected, and every statement is related, and also the except the quantifiers, all the meaning is same. You write like this. And then when you have a statement like all dogs have bitten a person, then what is that we can do here is you consider this as a partition because this is common for these actions. Three actions are common for all the three statements. You take it as a partition and take a general statement. This is a general statement. And what is this is G. G is a general statement. And what is the nature is like, what is this form that you are doing is, this is a form. What type of form is like, the earlier, like all dogs have bitten a person. So what is that we do is we just have this for all. So what does this partition semantic networks will tell you is you have three statements where the actions are same and the actors are same, but the quantifiers are different. Then what we do is we try to find this type of partition and then add this, like if for the second statements all dogs have bitten the person, what is that we can do is we can do like this. You can take it as a GS means a general statement. G is a general statement that I have taken. What type of form it is for all X, because all the dogs have bitten all the persons. If somebody says all the dogs have bitten all the people, then you can take some other general statement here. Like you can take a general statement like this. G1. G1 will have a form. Form. That form is for all X. So if this diagram will say that all the dogs have bitten all the people or all the pets, or something like that. This is a partition semantic network, and people will ask you like, can you write the extensions of semantic network? Can you just tell the disadvantage of semantic network and why this extension of semantic work is working, something like that? But all the semantic networks that what we are discussing today are theoretical concepts. Like we can and now we have many expert systems which process the statements and tell you whether the inference is valid or invalid, something like that. So these are the first two topics that we have to discuss in this particular class, like what are semantic networks and what are extended semantic networks or something like that. So many times this question was asked, many times even for your seniors, every time this question will be asked to draw the semantic network, and they will ask you various set of questions, what type of inferences that you can get from this network. And then they will ask you, can you represent, like if there is a statement like all the mammals are animals, we cannot represent in a general semantic network, then we need to go for a partition semantic and the story you have to write. So then after this, you have a very important concept called as conceptual dependency. Conceptual dependency is very important in the context of people who are aspiring to do some research in NLP. So conceptual dependency, what is the main aim of conceptual dependency is whatever language that you talk, whether you express yourself in English or Telugu or Tamil or Chinese or any other language. If the meaning of the statement is same, the knowledge representation must also be the same. You give set of NLP statement, you get some knowledge representation. And this knowledge representation has to be unique with respect to the way in which you spoke, like whether you speak in English or Urdu or whatever language that you spoke, if the meaning of that statements are same, the representation must be same. The knowledge representation has to be same. So this is what it is. You give set of natural language processing statements for your system. You will get a knowledge representation. That knowledge representation must be same for if the meaning is same in whatever like language that the statement is in, whether it is in a Chinese or English, you speak something, Rama is a boy. So the meaning is same in Tamil or Telugu, whatever it may be, the knowledge representation has to be same. So when you say that knowledge representation must be same, then you have something called as idioms, which will help you to represent this knowledge. So we have in our syllabus, we have 7 idioms, but in a textbook we have 11. So we'll read this 11 idioms. Whenever people ask you about conceptual dependency, you have to write about this 11 idioms and then write about the importance of conceptual dependency, and we can stop. So is there a difference between like you have a statement where somebody has entered into the class, somebody has forcibly entered into the class. Is there a difference or both are same? See, I have a statement saying that some girl has entered into the class, and I have other statement saying that some girl has forcibly entered into the class. Is there a difference? Am I audible? Is my voice is audible?
Yes, sir.
Yes. Can somebody just tell me what is the purpose of drawing a semantic network? For inference. Then why do we need to draw a diagram and then infer? Because we have many other systems where there is no need to draw a diagram and infer. The reason is it's a old semantic network is a old traditional way of representing knowledge. And in semantic network, when there is a path from one node to other node, so the inference is valid. If there is no path, the inference is invalid. That is how we do. In in general semantic networks, what is the constraint is when you have quantifiers like existential quantifiers or for all, we cannot represent that in the terms of a normal semantic network. That is the reason we have gone to this extended semantic networks or partition semantic networks where you have three statements where the actions are same, the actors are same, except the fact that you have different quantifiers. Then go for this go for this type of diagram, and you have a partition where all these actions are same, and keep that partition as a box, and then you represent these forms whether it is for all or existential, something like that. So next concept that I'm saying is about conceptual dependency, where we say that you need to output of conceptual dependency is a knowledge representation, but the knowledge representation has to be same for all the statements which are having the same meaning, irrespective of language that we speak. Conceptual dependency is very important thing where we need to represent knowledge uniquely and in the same manner if the semantics is same. Means the meaning is same, whatever language that you speak, whatever colloquial language or whatever language that you speak, if the meaning is same, the representation has to be same. So what is that we need to remember is when conceptual dependency is asked, just a minute. When conceptual dependency is asked, you need to think about 11 items which are very important. The 11 items, if you represent them, are 11 primitives that you remember, then mostly this conceptual dependency will be same. So now that I have asked, like somebody has entered into the class and somebody entered into the class forcibly. Somebody has entered into the class, took a textbook, and a robot has entered into the class, shifting some one book from one class to other class. There are different meanings for every statement. So a lady has entered into the class will have a meaning. A lady has entered into the class forcibly will have a different meaning. A girl is listening to the class will have a positive meaning. A girl is doing noise in the class will have a negative meaning, and so on and so forth. So we have 7 to 11 primitives that we have in conceptual dependence to remember. So whenever we represent knowledge, we use all these 11 primitives, but now these 11 primitives are increased to 26 or 28. So we discuss only about these 11 primitives in this class. So a lady has entered into the class and took a textbook. We can represent in the terms of A trans. A trans is a primitive because if you write A trans in Prolog, the system can recognize. It will tell you about the abstract transfer, like whenever I write, I use something called as give, take. I will use this I trans. I went to a restaurant and I gave some money. So then you have to use A trans, like you are giving something, you are taking something. It will tell you about an abstract relationships, give or take, whatever it may, which is a very important primitive. Then there is something called as P trans. And then we'll talk about M trans. So I am moving from one place to other place. I started from Bembaram and reached to Vijayawada. So there is a transfer in the terms of location of the object. So we use this P trans. So then go, etc. You can use this for P-trans. P-trans, whenever you use a P-trans, the meaning is there is a physical location change for this object or the person. So I am giving something, I'm taking something, there is some output, there is a benefit or there is a loss, then I so go for A trans. When I am moving from one place to other place, there is a change in the place, then I go for P trans. And there is something called as M trans. All these are primitives that are used in conceptual dependency to represent knowledge. This is what we need to understand. M trans is to talk or to tell something which is positive. I'm taking a class, I'm talking. So that is, we call it as M trans. It is how you transfer this mental information, like what you have in your mind, you're telling something out. So then positively, you'll have this M trans. You are talking, you are taking a class, you are singing, all these positive vibrations when you do something in the terms of a mental transfer, we call it as M trans. So all these three primitives are very important. Whenever there is an action, like whenever there is an input given, you give something, you get something, we call it as A trans. And P trans, when you move from one place to other place, there is a physical change. M trans is to talk or tell whatever it may be in the positive sense. These three are very important primitives. And then you have something called as attend. Attend is also a primitive. What does this attend will tell you is attend is a primitive. It gives something like you focus your stimuli on some objects. Like I entered into this restaurant and I have seen where the empty benches are there. So that is where I have to use this attend. So I have entered into the seminar hall and seen where are the empty benches to sit. Attend is try to focus your stimuli or eyes on the possible options. You have possible options. We are going through the possible options. We call it as attend. Attend is to focus your stimuli on something like you see. I'm talking. You're listening. So listen will also will become an attend feature. Like attend means we can so something like listen. You're just focusing your brain on something. That is your attend. So A trans, P trans. So you have something called as a propel then. Propel is to apply force. Somebody has entered into the class forcibly. Then I have to use propel. We can use push or something like that. So you apply some force for doing some action. We have to use propel. So mtrans, I will use mbuild. All this mbuild, propel or attend, whatever it may be, the conceptual dependence in the textbook was written in the terms of robotics that we have. Mbuild is to decide. You take a decision, we call it as mbuild. So till now we have seen six primitives: A trans, P trans, M trans, attend, propel, and mbuild. Mbuild is to you have 20 or 30 options. You decide on one option, or you decide if you wish to take a decision. Then we say it is mbuild, which is very important for robotic operations. Mbuild is very important. It is like a case study, like a case. What it will do is it will have switch case. We have many options, and it's n, or it can be like multiplexer where you have n options. You'll get the output. One output. So attend is to focus your stimuli. You explore all the options. That is what your attend is. You listen to the statements. Then you take a decision. Then we call it as mbuild. Properly is to apply some force. A trans is your abstract transfer. You will be having a benefit, or you will also have a, you give something, so you lose. P trans is physical movement. M trans is to talk or tell or something like. These are the six primitives that are very important, and the other primitives we'll see. Whenever we talk about p-trans, there is a physical moment you need to think about. There is a primitive called as mu. A mu means like whenever I use a mu, it is morely, there is no physical transfer like p-trans. There is a physical transfer of the body. In mu means you move the parts of your body, but there is no physical transfer. So p-trans and mu are opposite in the terms of primitives. M-trans is to talk, and you have for something called as speak, which is the meaning. Speak is like you make some noise. You you disturb the class, or you're speaking loudly, you're doing a noise, you're uttering a noise or something. All these are also idioms, like in conceptual dependency, or primitives in conceptual dependency. And these are also very important. So this, you have an A trans, this is one, this is primitive, P trans 2, M trans 3, attend 4, which is very important, 5. Among all the 6, this M build is very important. And mu is just opposite to P trans. Move the parts of the body. So there is no physical movement. Then I will use this mu. This is 7th primitive or idiom. Speak is a negative sense of talking, like you disturb the class, you utter a noise, you shout, talk loudly. We use a speak here. This is the 8 primitives that we have discussed. The ninth one is very simple. You have something called as expel. Your expel is something which is coming outside like sweat or cry. So it's very humid, and I'm getting sweat. I'm emotional. I'm crying. So something which is coming outside, we call it as an expel. And ingest is to consume something inside, eat or something. And grasp is to hold. A robot is holding a book, so that we use that time we use this grasp. All these are 11 primitives that are very important, and everybody has to remember this, because without conceptual dependency, people will not ask you queries in this particular unit. This is the ninth primitive, which is very important. This is the 10th one. This is the 11th one. Ingest is to eat something. Grasp is you have holding a like I'm holding a fork to eat something. So then I use a grasp. So the grasp is a keyword in Prolog. MBuild, all these 11s are keyword in Prolog. So with all this, the conceptual dependency can be implemented and represented. This is what the story is. So expel is like cry or sweat. Ingest is to consume something. Grasp is to hold some object or something like that. MBuild is to decide. Among this all 11, this MBuild is very important and vital. In general, when I use MBuild, the previous statement, many times I use this attend. So p-trans is you have an object which is moving from one place to that place. Move is also like that, but there is no physical movement of the hands, movement of the body parts without changing the position. M-trans is to speak something, but speak is creating noise, speaking loudly in the negative sense. So all these are 11 primitives which are very important in the context of conceptual dependency. So if you remember how we have started the class today is, I said like you are going to discuss something called as semantic network. Many times semantic networks will be called as SN, extended semantic network, or partition semantic network that we have seen. Then I thought like conceptual dependence I said is very important. Then I said scripts are important. So what does conceptual dependency will do is it will take a statement and it give a representation. What does script is will do is script is a collection of scenes. So scripts will use the conceptual dependency and represent the knowledge. So last time when I'm taking a class, I said like I went to a restaurant and have consumed some food. So for that we have written some scenes. So that we will discuss and then try to conclude this after attempting the questions from your question bank also. So script is a very important concept in NLP, where script tries to use the conceptual dependency, but script will consist of set of statements which are connected or set of scenes which are connected. Script is one way of representing the knowledge, but script consists of set of scenes. Like I went to a restaurant, we can have different types of scenes. Like I enter into the restaurant, then I consume some food, like I order something, then I consume something, I pay something. All this can be somewhat uh, the scenes. Like if even when you the daily routine that you have in SVCW, you can have a scene. Like you woke up in the morning, that is a particular scene. So then you attended your classes in the morning, that can be represented as a scene. Then you consume food in the hostel, that can be represented as a scene, and then you go back to the hostels and do whatever you like. That can be a scene. So a script is a more form of like you connected a more number of natural language processing statements which are connected, and all these connected statements at some point of time we call to the scene. Scene 1, scene 2, scene 3, scene 4, scene 5. Some scenes can happen parallelly, some scenes can happen in sequence. So in Prolog, we have set of a very easy way of representing the scripts. For a script to represent, we need to have a name. Like I said last time when I taken class, the script that we have taken is some restaurant script. Some restaurant we went. So there can be any tracks in that restaurant. We have many shops, so you can have a track. The track is optional there. You went to somewhere in an ice cream shop or something like that. Where I said a restaurant consists of many shops. It can be an ice cream shop or it can be a biryani shop, whatever it may be. You have many tracks are there. So the track is optional. The names of the tracks are optional. So these properties that act I am writing is very important. Properties are what you have in this ice cream shop. You can have ice cream shop. Assume that you have menus, you have tables, you have some food to consume. Something like that. You can write whatever you like based on your perception and the description that was given. And these properties are not an optional field, it is a compulsory field in Prolog. And their rules, that is very important. Like you have, I went into some restaurant, so you will be the customer. You have somewhere you have some cook the food, and then you can have whatever it may be, waiter or whatever it may be, whatever you wish to write, you can write. So every script in Prolog will have all these fields. You have an optional entry conditions. Entry options are, yeah, input and output will say exit. So the entry and exit conditions are also optional. What is very important in writing a script is what is compulsory is you need to have a script name, you need to have properties, you need to have roles. After that, this track and entry and exit conditions are you can write or there is no write. Entry means I'm hungry, I came to the restaurant. Initially, when I'm entering to the restaurant, I have more money. After consuming the food, I have paid the money, so the money will be less or something, whatever you wish to have, you can have. So conceptual dependency, you represent the knowledge in the terms of a single statement, whereas script, you represent the knowledge in the terms of multiple statements, which is very important. That you need to remember. So then you can have your own properties like properties means you that does not have existence, life. So you can have menus, tables, foods, benches, whatever it may be, a food or many properties, whatever properties that you wish to have, you can have because it is in just imaginary restaurant that I have taken 3 or 4. The roles you can have a customer, a cook, a waiter, a owner, whatever it may be, you can have based upon conception. A script is a collection of scenes, which is very important. Every scene is also maybe connected or independent, but the operation can be sequential or parallel. So that's what I have done something in the class. The same thing I will do again here. Like I have something called as a restaurant script, where the restaurant I have a scene called as I enter into the restaurant and I order some food and then consume the food. Assume that you have 3 scenes, and as per the earlier slide, we have customer. C is a customer. We have something called as CO as a cook. There is somewhere called as a waiter. There is a waiter. And we have set of properties that we have menu, tables, food. We have something called as a menu, tables, food. We can call also this as actors like a role, whatever it may be. This does not have any physical money or something. So the interest of part is like enter into. I will write something about the enter, then you can understand how these things are done. I'm hungry. I entered into a restaurant and I ate something. Assume that the customer is C somewhere into restaurant. Assume that I'm in home and I went from home to restaurant. What type of primitive I have to use? Can somebody just tell now? I went from my home to the restaurant. What is the primitive I have to use? Yes. Then whatever I wish to have is I need to only have P trans. I went to the restaurant. I have seen various benches. So C dash benches means what I have used here. Tables. CP somebody's tables. Okay. I have seen all the benches. So if I wish to use, I have seen all the benches. What primitive I have to use here? attend. Yes, what you said is right. So this is very important. I have focused my stimuli on T, that T at this moment is tables. So many tables are there, and then I have decided somewhere to sit. So n inputs are there. I have taken one input. Now I have selected one from n. N inputs are there. I have selected one from that n. What primitive I have to use? Mbuild. Mbuild is to this. Yes, yes. Mbuild is where I have to decide. So mbuild. That's what it is. So then you can use like then once I decide that I have to sit somewhere, I will go to that place. See, what is the next thing I have to do? See, I have focused my stimuli there, and then I have decided to sit there, and then I need to go there. So what primitive I have to use here? See, I entered into the restaurant, you have used ptrans. Then I have seen the tables, you said it is attend. Then I have decided where to sit, you said it is mbuild. Then I need to go to that particular place and sit. So then I have to use, I have to physically move to that place and sit. Is it right? So what primitive I have to use? I have to use?
Patrons.
Yes, yes. I have to use a ptrans to the table, and somewhere I sat. Still I wish to use like he was sitting into some, if I say it is something called as sat in the position or something like that. If I write, what can I use here? What type of primitive I can use? C went into that place and sat in some sitting position, or the position where you can access the menu or something like that. This person entered into the restaurant. He has decided where to sit. He sat there, and he's he's not moving, but he's in a place, but he's going through the menu or something like that. What can what is the primitive which will tell you like there is a movement, but there is no motion from one place to other place? P-trans is a primitive where it will tell you like there is a movement from one place to other place. Move is an idiom where you can use it when there is no physical movement, but there is a movement of hands. I can use that move. Is it right? So if you wish to still use that primitive, I can use a move here because you sat on the table and you are moving. So there is no physical transfer. If you wish to use that, you can use it here because the semantic network diagrams are the script programs that we write. It is not unique with respect to all these people. Like I have 30 students now online. All these 30 will have different types of scripts based on the perception and understanding. And this enter we call it as a scene. This can be a scene one or scene two or something like that. So you can have any number of scenes like this. Scene two can be there, where two can be something called as ordering or ordering food or something like that. So assume that the customer has asked for a menu. Customer means see, ask for a menu. What is that I have to do? Customer has asked a menu if it is not available. What primitive have to use? Customer has asked a menu for to this waiter or something. Asked means Is it a speak or mtrans? Customer has asked for a menu. So is it mtrans or what? When can I use mtag is mtrans will have a proper positive statements like talking, speaking, and speak means you do noise, you utter something which is needed at the time. So a customer has asked for a menu means what I have to use? To use an mtrans. The customer has asked for a menu, like mtrans is you speak something which is positive. Then what can be the other statements? Assume that the waiter retrans to the table that you are having. Retrans means is moving. And he gave, this waiter gave the menu. Gave means what type of things that I have to use here? What script that I have to use?
A-trans.
Yes.
A-trans.
So WA trans menu to C or whatever it may be. Then this customer has gone through that menu, gone through or focus the stimuli means I have to use
Attends.
the attend. So I have gone through the menu and I have decided what to eat. C dash to eat. I have decided to eat
Ambil.
something. Yes. Then again, C trans his decision to the waiter and so on and so forth. You can write your scene as per as your convenience and perception. That's what it is. So when you represent knowledge in the terms of scenes, we call it as scripts. When you represent knowledge in the terms of statement, I have only statement. Conceptual dependency can only process one statement at a time. Script uses the conceptual dependency primitives to represent a set of scenes. Mostly the scenes are connected and mostly the scenes are sequential. But Prolog, there is an option for this sequences scenes to be parallel also. That's what it is. So all these are very important concepts in this particular fourth unit. And there is another simple concept which is very not important, but it is already read by you in database management system. Like what is an attribute in DBMS? Can somebody just tell me? What is an attribute in DBMS? See, employee will have some set of attributes. Employee will have name, employee will have ID, employee will have mobile number, and so on and so forth. Can I say the attribute means the property of an entity? Yes or no?
Yes, sir.
What is it? Yes, yes,
Yes, sir.
yes, yes. So, ID means every ID has to start with 5 or 6. They have some set of conditions. In your artificial intelligence, what is that we do is the attribute we call it as slot, and the value that you store we call it as filler. Slot is the name of the attribute. Filler is the value that can be stored in that attribute. Rama is a filler and name is a slot, something like that. So what is that we are going to just discuss within 1 or 2 minutes is a frame is a informal database management system for Prolog. And what does this frame will do is assume that there is a hospital. In the hospital, the attributes can be location, employees. I'm not describing this because you need to give a description. Location is what, employees are what, equipment. And I said there is a concept called as frame to represent knowledge. In that frame, what is that I had done is you have set of hospital called as the name of that hospital can be there. So I will write also the name. And there is other hospital called as dental hospital in this. Dental, assume that it is a subframe. And this dental hospital will also have a name, location, employees, equipment, but it will also have some special attributes. Assume the dental hospital will have a special equipment or whatever it may be. And there are some attributes for this. You have some hospital called as gynecology that we call it as the subframe. And whatever we represent here, like frames or database name systems in our artificial intelligence, like you can represent data and you can represent data in the terms of attributes. We call it as slots and filter. The names are different, but the concept is same. Like when you draw a AI diagram, I draw a AI diagram. The output of AI diagram is a table should not. AI diagrams, when you draw, there's no where you can represent this foreign keys or something like that. So the output of AI diagram is a table where you will have primary keys as well as foreign keys, and the tables are connected. This is how this unit is. If you still further explore this unit, you have something called as what is the problem in the terms of uh, knowledge representation, or the problem in the terms of AI is AI systems, most of them are trained systems based on the training and testing. They will move from one state to other state. The basic thing is the common sense. In AI, many times applying a common sense they cannot apply because even when you are doing this conceptual dependence in the terms of robotics also, you have set of rules. Based on that rules only, the robot will move from one place to other place. A robot cannot apply common sense instantly without being trained. That is the reason we have a database called as CYC. CYC is a collection of a database management systems in the terms of common sense. Like you can various domains. Like you have a domain called as health informatics. You have a domain called as insurance sector. So when you have a robot or when you have an expert system in these domains, what is that we do is what type of common sense is required. The CYC is a common sense mechanism in the terms of a database, and you wish to include the statements in that CYC, you have to use CYCL. CYCL is a language, and CYC is a database management system. It is something called as the CYC operates based on the ontology. How do you store data in the terms of meaning of the data? You store data in the terms of content. You store data in the terms of meaning. We call it as CYC. And based on that, if you wish to develop common sense database, I need to have a language called as CYC. And this is what the entire fourth unit talks about. So what is that now I do is just I have this question bank also. We'll see what type of questions are given. Even in the external exam also have given that question bank to the external people. They will also go through this. So John gave a book to Mary. So what primitive I have to use? Can somebody just tell here?
A-trans, sir.
Yes, A trans is an absolute transfer. Then I have to use that A trans. It seems to be what you said is right. So I have to use A trans. John is Eating ice cream. He's consuming something. Consuming means what?
Ingest, sir.
I have to use ingest, yes. So whatever you write in the LHS or RHS, what is that people will do is they will think about this ingest only. John is having a book in his hand. John is having a book in his hand. Is it A trans or P trans or grasp or expel or ingest or attend, propel or unbuild? Is having something. I'm
Sir.
grasp is. I have yes, a fork to eat. So holding something is grasp. I need to have a grasp here. John is shouting on Adam.
Speak, sir.
Shout,
Entrance.
shouting means speak. Entrance is a positive sense. Speak is how do you do noise? So speak you have to write here. Shouting means it is undesirable aspect. So obviously you have to use the speak that. John is thinking to go out. He's
Entrance.
thinking. Entrance is to speak something. Thinking means you need to decide something. Kada. He's applying his
Unbuild.
intuition. Build I have to use. So this is how it is. To draw the partition semantic network for the following statements. So this is what we have seen. The dog bit the mail carrier. Every dog has bitten the mail carrier. Every dog in the town has bitten the constable. Every dog in the town. So you have to create an instance here because in the town they have mentioned. So every dog has bitten every mail carrier. So you have to write this general. This is what we have to do. This is how the representation is. The same thing. The dog I have taken and the bitten and the person are same. So obviously this we have discussed. So develop the procedure to represent knowledge using semantic network. Then you need to take set of statements and then you have to explain. So obviously inheritance is used in semantic network. You can explain the same thing with respect to the example. Discuss the importance of scripts in depicting a scene. You can take any scene, whether it is a restaurant scene or coming to the institute and going back. You represent a script in the terms of set of scenes, but a script must have a script title, and then you can have a track, then you can have properties, you can have roles. Roles means there is no physical existence. Roles means there is a physical existence. Properties means there is no physical existence. Then you can have set of scenes that can be done parallelly or it can be sequentially. You can have entry conditions as well as you can also have exit conditions. All these two are not essential. It can be optional. So frame, I said, frame is your database main system. It is how you have a slot and filler structure. See, what is that? Many times I forgot to just have a overview is like whenever you're writing the exam, you have something like this. Many textbooks will follow the same slot and filler structure. Slot and filler means you have something called as weak, you have something called as strong. Strong way of representing knowledge, weak way of representing knowledge. Weak way is semantic networks. Weak way is frames. Weak way is extended semantic networks. Strong way is conceptual dependency. Scripts. If somebody asks you what are the strong slot filler structures, you can write conceptual dependency and scripts. Weak way means you have to write extended semantic networks, and frames. This is also important in the context of external exam. So explain frame, you can write how knowledge representation can be done in frames, you can write. So discuss the importance of extended semantic network. You can write the partition semantic network. Elaborate the importance of whenever conceptual dependency is asked, you have to write about the relevant primitives. Compare and contrast conceptual dependency and semantic networks. So you can write about semantic networks. You can write the disadvantage of semantic networks, then write advantage of conceptual dependency. But you have to write all the primitives again. To discuss with an example of scripts, you can write that. Explain how you can represent the restaurant that we have seen, restaurant or whatever. So the fourth unit is a very easy unit that you can attempt the questions. So in the afternoon when we meet, we'll discuss this fifth unit. Did you complete the certifications?
Yes, sir.
Yes, sir.
In afternoon or